Okay, so now we get to the fun part of algebra. Well, I think it's fun, and I hope that you think it's fun as well. Factoring polynomials. And of course, the beginning of this is just page 1. All you need is page 1, and we're just going to do page 1 today. We're going to talk about factoring out the greatest common factor in this video. It's just one page. There's so many different types of factoring. And if you like a challenge with numbers, you probably will enjoy factoring. So I hope that you do. I hope that you do like this process of factoring. Factor means divide, so you're going to divide something out. Okay, when you find the product of something, that's multiplication, and then when you undo that product, that's division, and that's what we call factoring. It's the process of writing a polynomial as the product of two or more polynomials. Product of two, that's the minimum, two or more polynomials. Okay. Polynomials that cannot be factored using integer, right? That's like positives, negatives. We don't really want 0 because, 0 times x is still 0. But we're going to use integer coefficients. All right? No fractions, in other words. Okay? No rational numbers, just integers. Polynomials that cannot be factored using integer coefficients are said to be prime. Like you're familiar with prime numbers. 5 is a prime number. Why? Because it can't be broken down into anything else except for 1 times 5. So prime number is divisible by itself and 1 only. And so we can't break it down anymore. We can't divide it by anything else. And since factor means divide, if we have a polynomial that we can't break down anymore, then we say it's prime. It's down to its lowest form. In any factoring problem, any and every factoring problem, the first step is to always first look for the greatest common factor. My pen writer is trying to act up again. All right. Greatest common factor. Folks, you should know this or have heard of this as the GCF, greatest common factor. That's the first thing you always look for. Even in the problems that are more challenging to factor, we're always going to first look for a GCF. When you take a GCF out, it makes it easier to factor. The GCF, or the greatest common factor, is an expression of the highest degree that divides each term of the polynomial. Okay, it's the largest thing, hence greatest, the largest thing that will divide each term of the polynomial. And we're going to get to some examples. Like if you look down here and look down yonder, okay, 12x to the power 4 minus 8x squared. This is a polynomial. And I want to take out the GCF. So I'm going to look for the biggest thing that divides 12x to the power 4 and 8x squared. All right. Factoring is reversing multiplication, aka it's division. All right. Factoring is reversing polynomial multiplication. You're dividing out common factors. All right. Let's look at example 1. Factor out the greatest common factor. The question here is, and these are the questions that you need to ask yourself, using your inside voice when you're doing these problems. What does each term have in common? Sometimes it's nothing other than 1. But if the directions are for you to factor out the greatest common factor, more often than not, there is going to be a GCF. There is going to be some greatest common factor. So if I'm looking at 12x to the power of 4 and 8x squared, you know, I'm looking at 12 and I say, well, 2 divides 12 and 2 also divides 8 because they're both even. But is there something larger that divides 12 and 8? Well, it can't be as big as 8 because 8 doesn't divide 12. You know, but I could break this down and say, you know, this is like 2 times 6, and 8 is 2 times 4. But look, this 6 and this 4 is still even. So this is really 2 times 2 times 3, right? Because the 6 can be broken down. And this is a 2, and guess what? This 4 can be broken down into 2 times 2. And so I look and see, what do these two things, the integer part right now, have in common? Well, this one has 2 2's, and this one has, in fact, 3 2's, but I can only take the same thing out of each one. So guess what? In this example, my greatest common factor is 4, because 4 is going to divide 12 and 8. That's the biggest thing. So far, the numeric part is a 4. All right, let's look at the variable part. That's x to the 4th. This is x to the 2nd. You know, I look at this term, and I don't know. Sometimes I just call them guys or girls, you know, and I'm like, oh, 12x to the 4th. How many x's does he have to give up? Well, you know, this guy has 4 x's that he could possibly give up. You know, x to the power of 4 is x times x times x times x. But this guy over here, he's only got 2 x's to give up. So what do they have in common? The most I can take out of each one is 2 x's. And so back here into building my GCF, or what do they have in common? You know, 4x squared is the biggest thing I could take out. And so when I go back over to now actually factor out my GCF, I put the 4x squared on the outside. And remember, I'm reversing polynomial multiplication. So I have to write it as a multiplication problem. And then I ask myself, well, 4 times what is 12? Well, that would be a 3. X squared times what is x to the 4th? Well, that would be x squared. Or, you know, think of it as an actual division problem. 12, I'll undo this then. 12 divided by 4 is 3. X to the power of 4 divided by x to the power of 2 is x to the power of 2. So there's a couple different ways that you could think about how to do these and how to set it up. Usually, typically, students will say, well, all right, the 4 and the x squared is coming out. 4 times what is 12? They do it that way. It doesn't matter which way you want to do it. All right, so here, the sign is going to be negative, right? Because this is a negative number divided by a positive number. 8 divided by 4 is 2. And x squared divided by x squared is 1, so I'm finished. So my final answer here is 4x squared times the quantity 3x squared minus 2. Folks, you need to have both of these as the answer, because it's the multiplication of these two polynomials, this monomial being multiplied with this binomial, that's going to give me the original problem. All right, let's move on to the next one and answer the question. What does each term have in common? Well, you know, here I've got a 15 A, B, and then an 18 B, C, and then a 21 B times D. All right, that 15 is, there we go, fixed it. So I'm looking at the integer part of all of this, the numbers. And I'm like, well, 5 times 3 is 15. 6 times 3 is 18. And 7 times 3 is 21. So it's looking like I could take a 3 out of each of them, right? Because, again, this was 3 times 5. This was 3 times 6. This was 3 times 7. And remember, it's got to be something that comes out of all of them. So I can factor out a 3. 5 can't be broken down anymore. 6 can, but it's not going to give me anything that the 7 or the 5 has. So I'm done. I know my GCF for the numeric part is 3. Now I have to look at the letters. This got an A, this doesn't. So I cannot take an A out of any one of these. They all have to have an A. They all have to be able to give up an A. What do they all have in common that they can all give up? All right, well, if you said B, you're correct, because that's 1B, that's 1B, and that's 1B. So I can take a 3B out of each of those. Look, this one has a C, but the first one and the last one doesn't. So I can't pull out a C. Remember, it's got to be something that they all have in common, not just 1 or 2 terms. And again, for the same reason, I can't take a D out. So my GCF is 3B. Now I'm going to go back over to my problem, and I'm going to factor out the 3B. And remember, factor means divide, so I'm going to write it as a product. 15 divided by 3 is 5. A didn't come out, it stays in. B came out. B over B is 1. The sign is plus. There's no well, there's a negative over here, but this is positive. Divided by positive is still going to be positive. 18 divided by 3 is 6. Remember, the B came out. The C stays in. Negative divided by positive is negative. 21 divided by 3 is 7. The B came out, right? B over B is 1. So that would be 7 times 1, which is still 7, times D. This is my full answer. Remember, I'm not asking just for the GCF. Over here, we're asking just for the GCF. This is the GCF for this problem. But the answer to the problem, factor out the greatest common factor, is the GCF on the outside of the polynomial that remains. So keep that in mind. Students do that all the time. They write just the GCF. You can't just write the GCF. You need the whole thing. All right. The next one might look a little tricky. Now, remember, we're factoring out common factors that terms have in common. You know, if I look at example B again, this is one term, and I'm highlighting it. This is a second term, and this is a third term. Now, terms are separated by addition and subtraction. Okay, that's how we tell what terms. You know, these that are connected together by multiplication, that's one term. And then when you see a plus, an interruption in between, then you're on to the next term. Okay? So when I look at example C here, right here, and I'm going to do this in green, right here is my subtraction. And here is my first term, and here is my second term. And now I'm asking you, if you see it that way now, what do these two terms have in common? You should see that they both each have a quantity x plus 5 in common. Now let's look at this part here, 3x on the outside. This is just a 2. Well, 2 and 3 are both prime, so they have no common factors other than 1. So the GCF for this problem is the quantity x plus 5. So remember, I'm going to factor it out. All right, so it gets moved out to the front. I'm going to factor it out. And factor means divide, so what's left is going to be a product here. Now, I really want you to start seeing this as division. So if I take this term and I take this term and I divide them both by x plus 5, then guess what? These x plus 5s are going to divide out, and these x plus 5s are going to divide out. And what's left? Can you see it? Well, maybe I'll do it in pink. Can you see it? 3x did not get divided out, and the 2 did not get divided out. This minus, we got to keep it. It's got to stay. So what's left is 3x subtract 2. Okay, this is my final answer. You know, if I take 3x and multiply with x plus 5, I do get 3x times the quantity x plus 5. And then if I take negative 2 and multiply it with x plus 5, I do get negative 2 times x plus 5. So think of it that way. I want you to start thinking of factoring as division. All right? And so it's probably best if you don't say, well, what times this equals that? You just say, divide the first term by this, you're left with 3x. Divide the second term by that, you're left with negative 2. Now, having said that, just make sure you write this one time. It's getting divided out of each of those just once. You do not write this 2 times. That's just what they have in common. The thing they have in common gets written on the outside just one time. You see here, this was my GCF. It gets written on the outside once. My 4x squared was my GCF. That gets written on the outside one time. I know you see x plus 5 here twice, but it's getting divided out of each one time. So you only write it one time. Okay? If you make this mistake on a test or a quiz, I'm going to know you didn't listen to my video. Okay? Maybe I'll write on here. Listen to the audio. I know some of you do, but I know some of you don't. So, I don't know what to say. I try to do my best to help you. And, I don't know. Hopefully my best is good. All right, so listen to the audio here. This is just going to come out one time. That's the GCF. Okay, it's going to divide this and this. And you're going to be left with 3x minus 2 right here inside the parentheses. And if you didn't have the audio on up until this point, you're probably going to want to rewind it a little bit so you can hear what I said. All right, back to purple. Last one. What does each term have in common? Well, I'm going to look. My numbers are 12. This is the integer part. 14. And 18. All right, so I'm like 6 divides 12 and 18, but not 14. 2 divides 12, 2 divides 14, and 2 divides 14 7 times. So I'm thinking 2 is the GCF here. You know, even though 2 divides 12 6 times and I can break 6 down, that's not going to help me with taking something else bigger out. It's just not, because 7 is prime. 7 is 1 times 7. And again, 2 divides 18 9 times, and although 9 is not a prime number, 9 doesn't have any factors in common with a 7, again, for this very same reason. So for the numeric part, my GCF is 2. Now I have to look at all this. Oh, geez Louise, this is busy. Okay, first guy. Now remember, here's my terms. This first term plus second term plus third term, okay? We don't want to have to write everything out over on the side. It's going to take me too long to get done with a test or a quiz. We're just learning it right now, but once we get better at it, we want to, you know, fly a little bit faster and not have to write everything down. So just remember, terms are separated by addition and subtraction. All right, so I'm going to get rid of those boxes. You're going to go? Okay. That's all right. I could rewrite the 2. So the GCF for the numeric part is 2. But I'm not done. I got to look at this. This guy's got 2 x's to give up. This guy's got 2 x's to give up. This guy's got 2 x's to give up. As long as they all have the same amount, I can take them out. Since they all have x squared, I could take an x squared out. Look at the first term. This guy's got 2 y's to give up. This guy's got 1 y to give up. And this guy's got 3 y's to give up. Folks, the greatest common factor means the biggest thing that each one can give up at the same time. What do they have in common? Well, I can only take a single y from each one. And I'm going to factor it out, and factor means divide. 12 divided by 2 is 6. X squared, look, they both came out. This had 2 y's, 1 came out, so 1 stays in. Or y squared divided by y is y. Sign is addition, positive over positive. 14 divided by 2 is 7. Both x's came out, right? X squared over x squared is 1. 1y came out. Okay, so I'm done with this term now. Plus 18. 18 divided by 2 is 9. X squared, see, they both came out. X squared over x squared is 1. I mean, we're not going to write times 1. It seems silly to do that. This had 3 y's to give up. We took 1 out, so 2 stay in. And now it is customary to put this thing in standard form because, you know, we're used to seeing, you know, second power, first power, no power. So you really should take the time to rearrange it. I will say, during this whole factoring extravaganza that we're going to be having going on here, and it's going to take a while for us to get through factoring and all the different types of factoring. Sometimes I give you worksheets that are the Algebra with Pizzazz worksheets. I'm going to require that you show work so that I know what your understanding is. They are puzzle worksheets, but if you just Google the answer to the puzzle and have no work, first of all, I'm not going to give you credit. And second of all, that's not going to help you at all. The reason the puzzle is there is to help you know if you're doing it correctly, okay? Now, I know I always get some students every year that just Google the answers and they don't do the work. You're hurting yourself. So I just ask that you do not do that. I don't think the first homework worksheet that goes along with GCF, I don't think it is a puzzle worksheet. So it's the greatest common factor worksheet in the resources folder. I'm going to circle this as my final answer. You know, and the beauty of factoring and mathematics in general is you could check your answer. You know, I'm looking here. 2 times 9 is 18. Times x squared times y cubed. Well, that's this term right here. And then you could distribute this multiplied with this. Well, that's 6 times 2 is 12. Would you get that term there? And then the 7 multiplied with that, would you get that term there? You can check it to see if you're right by doing a distributive property, aka multiplying it out again. I'm not going to require that you do that on a test or a quiz. It's going to take you too long, but you can at least know in your homework if you're doing it correctly or incorrectly. Okay, you know what to do. If you have questions, come in a live Google Meet. Ask to do a Google Meet if you can't be there at that time. Or post on the homework discussion. Because I'm here to help you, but I can't help you unless I know you need help. All right, well, I hope this was easily understandable for you, and if you have any questions, please ask. Have a great day.